All right, cool. Can you guys hear me now? Sorry, I just did an update for my computer recently. I must have messed it up. There it is. All right, how you guys doing tonight? Welcome, welcome, welcome. We're here at the Understanding Behavior live stream. We are doing experimental design part 2. Who is ready? Looks like we've got some new people in the chat here. Welcome, Nat, first timer. We've got Amanda ready to get back on the study train. Let's do it. We've got Armion, I think. First timer here as well. Hell yeah. Welcome, welcome. Well, this is a part 2 here for the experimental design. So last week we talked about kind of the basics. We talked about single subject versus group designs. We talked about the how to do visual analysis of our graphs. We also talked about baseline logic, which is that prediction, verification, replication, all good stuff. Oh, never mind. Armion's been here before. Well, welcome back. All right, Nissa, last few days of studying. Good luck in your exam. We've got Heather from Michigan representing the mitten. Hell yeah, hell yeah. So today we're gonna hop into our different experimental designs. We're gonna talk about what good, like basically like how they work, and then we'll also talk about their utility. So what situations we're going to use each one, and which situations they're not gonna be so great for. So gonna be a really cool one. You're totally good, Rachel. I'm glad you're here. Hey there, Danny. Good to see you here. All right, well, yeah, let's hop right into our stuff. Actually, I was kind of thinking I'll see what you guys feel about this, but I was kind of thinking to switch up these streams a little bit, and maybe we'll do a more formal procedure for it later. But maybe we'll take like 1 to 3 like random user question. So if you guys have had like a particular topic that's been bugging you recently, or just like an overall question, maybe we'll take like 1 to 3 of those before we hop into our main content. What do you guys think of that? Does that sound fun? And if you have a question, feel free to throw it in the chat. And yeah, it kind of gives you an opportunity to ask your own questions. We can switch up our topics a little bit too. We might do it like a submission process in the future. But if you guys just have like general questions or like something that's just been really bugging you, I'm totally down to take a couple of those. But tonight's topic is experimental design. So I'm talking non-experimental design related ones. And preferably ones that we don't typically do our streams on either. So yeah, so we're getting a lot of questions that are kind of like related to things that we cover. We had a question about sequence effects. That one we actually we don't go over too much in this presentation, but we can go over that a little bit. Essentially, like a sequence effect is when it's a very broad term that talks about a lot of different situations. Broad term that refers to lots of different situations. But essentially, this is like any time that the order that you present your different experimental design conditions affects our data in some particular way. So there's tons of these, and you don't really need to know all of them. Like if you're in experimental design and like you're just like, this is the last thing I need to nail down, then maybe go for it. But otherwise, don't worry about these too much. A lot of them are very similar as well. So a carryover effect. Man, I haven't talked about this one in a long time. So a carryover effect is essentially when there's like poor discrimination between the experimental design conditions, and we see like some transfer of the effects of the previous condition to the next condition. I'm pretty sure that's what a carryover effect is. I might be a little rusty on this one, but essentially, like, let's just say that in the last condition that we were in, that there was like previous reinforcement for a behavior. Then when we switch over to a new condition, like that behavior might still be persisting, regardless if it's like not getting reinforced in that next condition. So it's kind of like the effects of that previous condition are affecting that next condition. Cool. I like that one. That's a good question. But again, sequence effects, kind of a low, this is definitely a lower priority topic, so don't worry about that too much if you're getting really tripped up on those, because you don't really need to know for the exam. I wouldn't worry about it too much. All right. Yeah, it looks like CMOs are popular right now. A lot of people are asking about like generative learning stuff here. Some of those might be a little bit too deep for what I'm going for here. Nissa's got a great question about imitation versus observational learning. Observational learning. So let's talk about that one real quick. Imitation, this is like copying the behavior of a model directly after it occurs. So that's what we're referring to when we're looking at imitation. So with this, like the model needs to be present when the behavior of the imitator occurs. So that's one key way to differentiate between these two. Observational learning is essentially like a learner watches the consequences that somebody else experiences for a behavior, which changes the likelihood of that behavior. So a couple key differences between imitation and observational learning. For observational learning, this is more about like delayed imitation, would be one example. So this would be like the model is not present, but still like the person whose behavior that we're looking at may have done or may have like observed this in the past. But another key difference here is that observational learning can also suppress behavior. So let's say like we watch, a quick example here, let's say like we watch somebody else experience a punishing consequence. This may suppress the likelihood that the person would engage in that behavior in the future. So that's another key difference between observational learning, where with imitation, like the behavior is always occurring. With observational learning, we could watch them experience something punishing, and that would could suppress the behavior of that individual that might have had like a higher likelihood to do it if they hadn't watched that. Yes, good. I'm glad to see that. Awesome. Well, yeah, I thought this might be a cool way to warm us up, and maybe we'll do a more formal process for this our next stream. But yeah, I kind of just wanted to give that a little go, and hopefully you guys liked that. Was that fun? Was that cool? Well, let me know what you guys think, and maybe we'll play around with that in the future. All right, so today we are getting into experimental design part 2. We left off where we were just about to jump into all of our different designs. So we're going to start with that today. Just a quick note, if you haven't visited our stuff yet on understandingbehavior.shop, it's totally worth your time. So go ahead and do that. You can sign up for our email list, and that will show that will give you some reminders about when all of our sessions are occurring. You can do that right here. We'll also give you links to some of our mini mocks and then some coupon codes as well. So check that out if you are trying to get deeper into studying. We've got some amazing stuff here. Check out our B-Slayer course for like a really comprehensive overview of everything that you need to pass the exam. And we've got all of our amazing mock products on here as well. If you're looking for some bigger bundles, we offer some pretty big discounts in our Super Ultimate Mock Bundle with comes with all of our mock products. And then our Complete Beast Mode Bundle comes with all of our mock products, our B-Slayer course, and our fluency questions. All of these can also be consumed on our app. So pretty cool stuff. And if you're looking to pass your exam, check out understandingbehavior.shop and sign up for emails and stuff. Totally. Yeah, Heather's saying I gotta give that segment a cute name. Yeah, I totally agree. Well, this was very rough. I literally thought about this like 5 minutes before I came on stream. So I'm like, oh, here we go. Let's just do it and see how it goes. All right. Well, anyway, thanks for being here tonight with me. We are going over our withdrawal reversal designs first. So let's go ahead and do that. Probably the most familiar design that you guys know already. So main feature about our withdrawal reversal design is that we're going to be reversing between our baseline and intervention conditions. And what we want to look for is that we have like these baseline and intervention conditions, but they're separated by phase change lines. So these vertical lines here, these are phase change lines, and they note that we're switching what phase we're on, either from a baseline to intervention or to a different intervention. The main point here is that we're going to compare the levels of the behavior in the different conditions with or without the independent variable. So our baseline condition is going to be without the independent variable, and then obviously our intervention condition is going to be with the independent variable. Once again, for visual analysis, a couple of key things that you want to look for. First are going to be those phase change lines. And then you're going to see all withdrawal designs are going to have some kind of baseline or control condition. So look for that baseline condition. One more feature of this is that one of these conditions, either baseline or intervention, is going to occur more than once. So if you only see one baseline, it doesn't necessarily mean that it is a withdrawal design. But if we see intervention twice, or if we see baseline twice, then that is a pretty good indicator that we're working with a withdrawal reversal design here. This design is also good to go for testing out multiple interventions. So we might call this like an ABAC arrangement. So if we look at the second graph down here, that's exactly what we're doing. So A is always going to be our baseline. Then we have B is going to be our intervention condition. And then we see here that we have intervention B. This is a second intervention. And this is going to be called C in our chart. So this was an A, B, C, B, C. But oftentimes we do like this arrangement where it's like A, B, A, C. Totally valid as well. And yeah, somebody's mentioning, we talked about the sequence effect earlier, where we kind of see sequence effects occur in this design over here, where this baseline condition tends to reduce the rate of that behavior, but we see that on that first data point, they're not necessarily discriminating between that new condition yet, and the behavior is still occurring at a pretty high rate. So this would be definitely a sequence effect that's occurring there for sure. All right, in our withdrawal reversal design, you can also start with an intervention condition. So you don't always need to start with baseline. You can do a BAB arrangement where you're immediately putting that intervention in. Again, the key feature here is that we want to look at one of these conditions is going to be repeated more than once. So we have the BAB has that intervention condition more than once. Cool. All right, Amanda, we'll get to that in a little bit. Next thing to note is, when do we do a phase change? So a really important rule to hold on to. I wish I had an actual thing I could type here, because I would get too sloppy with a marker. But write this down if you're taking notes, is that trending data are likely to continue to trend. So let's think about that one more time. That rule is, write this down in your notes if you're taking notes, trending data are likely to continue to trend. We talked about this a little bit last week with our prediction verification and replication stuff. So most people know that. Actually, I'll let you guys try to figure it out. There's actually two different indicators that say we are good to go for a phase change here. So one of them is probably gonna, a lot of you guys are probably gonna get this one, and then the second one's a little trickier. Let's see what you guys got here. Again, we're looking at what patterns do we want to see in our data path for a phase change. Cool. Yeah, a lot of you guys are getting the first one. Nice job, Susie, Monte, Mina, King. Awesome. So that's going to be our stable data. So that would be kind of like what we have here with our baseline conditions. So we've got some really stable data. That looks pretty good. So that's one condition where we could do a phase change. Anybody know the other one? Ooh, Susie's on it. Kiyomi, give me a little bit more there. Monte, I think you're on the right track. I just need a little bit more there. Good. Yeah, Amy, killing it there. Awesome. Nice. Lots of you guys recalling this from last week. So we had stable data is the one pattern that we could look for. The other pattern is if the data are trending in the opposite direction intended by the next condition. So let's look at our second baseline over here. So this is not a very stable chart, but we still did a phase change. So if we were to draw this trend line, we see like it's kind of rapidly descending here. This is not a stable trend, but we still did a phase change. And indeed, this was an appropriate time to do a phase change. So we anticipate that our intervention condition is going to increase the frequency of this behavior, and we see that it's trending in the opposite direction by the next condition. So referring back to last week when we talked about prediction, verification, and replication, we talked about how our predictions are essentially like if we are going to continue that phase, then we're going to predict that the trend and level are going to stay around the same. So we would make this prediction here about the stable one that we're going to see this pattern kind of hover between like 1 and 3 and be pretty stable. For this one, we could predict that either this is going to continue to descend or it's going to stabilize out. Would be our prediction. So for so this is totally cool because this would be if we added in like another baseline phase that we would want to see like the verification there. But this is totally cool because we hold on to that rule that trending data are likely to continue to trend. So if we see that the next condition changes drastically the level and the trend of the behavior, like we saw here, there's a big change in level from like where our average level was here, where we stabilized out, then this can still show very good experimental control. So the only condition where we wouldn't really phase change would be if it's trending in the direction that is intended by the next phase. So if we had data points that kind of looked like that, then if we implement our intervention, we're not sure if it was just going to naturally increase because trending data are likely to continue to trend, or was it our intervention that caused that increase in the behavior? So that has two explanations for why the behavior could increase. And if we're trying to do an experiment, if we're trying to do some real science, remember we need to isolate a single independent variable or a single explanation for a change in behavior. If we did it like this, then we have two explanations, not so great, really harms our experiment. But if it's trending in the opposite direction intended by the next phase, doesn't harm our experiment at all, and we can still show really good experimental control. All right, that was kind of a lot. Is that all making sense? We feeling groovy on that? Nice, lots of you guys got that too. So remember, we can phase change if the data are stable, or we would do a phase change if the data are trending in the opposite direction intended by the next condition. Cool, cool, cool. I'm glad it's clearing up. Glad it's making sense. Groovy, groovy, groovy. So those are the main features of our withdrawal reversal design. One more thing I want to point out here is in our bottom graph, we actually have two independent variables. So B here would be our IV1. And then C here would be our IV2. But we also have two dependent variables. Dun, dun, dun. So we don't really have the labels for this chart. But if we're tracking two things on every single session, that is a good indicator that these are two dependent variables and not two independent variables. So what we want to look for is that there's two data points on a single session. This is another good indicator of a withdrawal design versus an alternating treatments design, and we'll look at that difference when we get to that in a few moments. So look at that. If there are like multiple data paths, are the data points aligning on the same session or are they aligning on different sessions? Really important to keep track of. But if we see that two are on the same session, then these are probably going to be two different dependent variables or two different behaviors. Cool, cool, cool. All right, so those are the features of that withdrawal reversal design. And remember, when we're trying to demonstrate experimental control, we always want to compare our level between our conditions. So we can do that real quick here. We can draw our level estimation lines. We wanted to kind of like take where they stabilize out at. So remember, we might have that sequence effect, especially in our like first data point where they're kind of just like acclimating to the condition that's going on. So sometimes we can cross off these first data points as outliers. It's like they're kind of just like acclimating to the condition, and kind of same thing for this one. And then we can draw our level lines of like where the data stabilized out, and that is totally appropriate to do. That line is not very straight, but whatever. So to tell if we have experimental control, what we want to do is we want to compare the level between our conditions. And to recap from last week as well, which phase here can we tell that we have good experimental control? Is this going to be phase 1, 2, 3, or 4? What do you guys think? So again, the question is, which phase are we able to tell that we have good experimental control? Is it going to be 1, 2, 3, or 4? Bonus points if you can tell me which part of baseline logic occurs there. Nice. Magdiel's got me on my bonus. Excellent. All right, so we're able to show experimental control in phase 3 here. So once we revert back to that original condition and we show that our prediction was accurate about that condition, we are totally good to go here. And you guys are nailing it. The term that occurs here is, in reference to baseline logic, is going to be verification. So kind of thinking about it, when we have our first phase, we just have baseline. So this meter right here that I'm holding is going to be like our experimental control meter. So we're kind of like 0 because we haven't really done anything at baseline yet. Then we do our intervention. It's like, oh, wow, that kind of like increased the behavior. So we're like a little bit more confident, like, okay, that did the thing. But when we remove that intervention, we see the behavior revert back. Then we're like, oh, yeah, that was the thing that caused that change in behavior, 100%. So we're like really confident. And then in that phase 4, we kind of just up that confidence just a little bit more. So in phase 4 here, we get replication. For our ABAB design, it kind of just makes sense that we're going to throw the intervention back in if it's working. But as far as experimental control goes, it only adds a little bit more. So like phase 1, we don't know anything. Phase 2, we're like, okay, there's a change. Phase 3, we're like, oh yeah, we're confident. Phase 4, we're like, okay, that did it for sure. Only a little bit more confident there. So looking at our withdrawal reversal designs, this has our strongest demonstration of experimental control. So some designs are better than others at showing experimental control. And the main reason for that the withdrawal reversal design shows really good experimental control is that we show the change in behavior with really clean, like, okay, everything's the same, but we add this one element, and then we take that element away, and the behavior reverts back. So the more that the more cleanly that an experiment like adds and removes an intervention, the better it's going to show experimental control. So we know that withdrawal reversal designs do that really cleanly. It's a really strong demonstration of experimental control, or it means we get like really solid data, or really believable data. One limitation of our withdrawal reversal design is that we cannot use it for behaviors that cannot be reversed or unlearned. So if we were to do that, what would be the issue? What would be something that we would not be able to attain in reference to baseline logic? Kind of a tricky question. So if we have a behavior that cannot be reversed or unlearned, what would be something that we would not be able to see? Good. Yeah, a lot of people are on the right track here. So let's draw that graph out real quick. So let's say we are looking at like percent of reading words accurately. Percent read accurately. And we're using like a very specific word set. Let's say that they like hardly know it at all in our baseline condition. Our intervention, it teaches them these words. So, okay, we see like a pretty quick ascending trend, and then it evens out at 100 here. And then when we revert back to our baseline condition, they like haven't forgotten it. They still know how to do it. So in this case, we would not see our verification. And that means that with this design, we wouldn't be able to tell if we have experimental control or not, because we only do this A-B relationship. So no verification, no good. So we can't use it for those irreversible behaviors. This actually came up in one of the tutoring sessions I was doing the other day, where I think it's really important when you guys are like talking about like these irreversible behaviors that you don't just say what the behavior is, but you also say the measurement of the behavior. So like a lot of people are just saying like reading, but what about reading? What measurement of reading? Like if it's reading speed, then this is actually going to be a reversible behavior that's going to be sensitive to environment conditions. If we're looking at, like, for example, like words per minute, if like my words per minute of like reading Dr. Seuss versus like words per minute of reading Skinner's verbal behavior, like that's going to be really different depending on those conditions. But if we're just, so it's really important to label what is the actual measurement, or what is the actual dependent variable that we're looking at, instead of just saying like a behavior like that. So like a better one for like, instead of just saying reading, would be like the like percent of accurately reading words, for example. And like once you have that word set down, it's like, okay, we're not really going to forget that very easily. But really important to kind of like more specifically label what is that dependent variable, just to not get so loose with it, or not get too used to like your same examples, and understand like what about the example actually makes it irreversible. For show. All right, cool. I'm glad we got to hit on that. Somebody mentioned this earlier, but with the withdrawal and reversal designs, there's also some ethical limitations with severe and dangerous behavior. So typically not the best design to do with those. If it's a less severe or dangerous behavior, sometimes we can do a BAB design, where they might only have like a little bit of exposure to that baseline condition again. But typically not going to be the best design here, because it requires that reversal of baseline, and we would be required to remove a potentially effective intervention, and that might not be so great. Cool. We talked about earlier that withdrawal reversal designs can be used to test out multiple interventions. So we saw that in this graph 2 here, where we have intervention A and intervention B. The one thing with this is that it's a little bit slow to do it because we need those very specific patterns of data before we can phase change. So if we want to test out lots of different interventions, like we might be here for a while. Like even with this 2 intervention chart, we see that it went up to 20 sessions. So pretty significant amount of sessions and data that we had to collect here. All right. That's going to wrap us up for for withdrawal designs. Any final questions on these before we move on to alternating treatments? Alternating treatments are fun. They're my favorite. Cool, cool, cool. All right, let's keep trucking along then. Next up, on to alternating treatments design. Who knows, what is the other term that we commonly use for an alternating treatments design? Nice, Amanda's got that. Catherine's got it. Kayvon's got it. Paige has got it. Nat has got it. Awesome. Looking good, looking good. So this is going to be also known as our multi-element chart. I guess it's also put it here. So multi-element, same exact thing as our alternating treatments design. Hopefully you didn't read my bullet next because it relates to my next question. What is the most unique feature about an alternating treatments design? What do you guys think? What is the most unique feature that defines an alternating treatments design? Or some people are saying it's fast, but what makes it fast? Some people are saying no baseline. There are other designs that don't need a baseline. No withdrawal. It does require. There's other designs don't require withdrawals either. All right, Susie's got it. Gunjan's got it. K23 Sky's got it. There we go. All right. I'm liking it now. Lisa's got it. Awesome. So yeah, most important feature here is that we're rapidly alternating between our conditions. This is the only design that is going to do that. Have our rapid alternation between our conditions. So let's look at our chart here and show you what that means. So alternating treatment conditions are designs we can do many different, test out many different conditions all at once. And we see that here. So each of these different signs and each of these different data paths is going to be a different condition. So we have our square condition here. That's our attention condition. Diamonds are our escape condition. Triangles are our play condition. So we've got 3 different ones that are being rapidly alternated between here. So we see that pretty much every session we're switching that up. So like session 1 is going to be our square. Session 2 is going to be our diamond. Session 3 is going to be that triangle. So we did 3 different sessions and they're all totally different conditions. We had one was escape, one was attention, one was play. So that's what we mean by rapid alternation. It's like pretty much every single session we're going to be switching up our condition. Sometimes we'll do 2 in a row, and that is totally cool to do. And actually oftentimes encouraged to do at least once. So, for example, we have our 2 square conditions here back to back. And that's just to show like, hey, if we did like continue on this condition, does it still continue? And that kind of helps us control for that sequence effect where it's like, okay, are they adjusting to the new condition fast enough? Yeah, Mina says she's getting confused by asking about like how many conditions there are and number of interventions. Let's talk about this one. So this is a functional analysis here. Well, how many different independent variables do we have, and how many total conditions do we have? Those might be different. Ooh. So in this, we're asking, in this chart in particular, how many different independent variables do we have? This is a really tricky question. The answer is 2. So this takes a little knowledge about our functional analysis. So we have 2 independent variables here. I think Gunjan actually nailed it here. We have 2 independent variables and then 1 control condition. So 3 total conditions, but 2 of them are serving as our independent variables. Our play condition is going to be our control condition. That's going to be our comparison condition. So a lot of people were saying, hey, can we do a multi-element design with, people were saying that we need to do a multi-element design with 2 to 4 independent variables. But, is there a way to do a multi-element design with 1 independent variable? Extra cool points if you can nail this one. And explain it, not just say yes or no. Cool points are only given for explanations. So again, the question is, can we do a multi-element with 1 independent variable? And if so, what would that look like? Oh, Laura chatting, getting some extra cool points here. Yes, 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 yes. Yeah, Kayvon, great, excellent. Cool. So yeah, I think this graph definitely like helps that see that demonstration, especially since we labeled our IVs and our control. So we could do an alternating treatments condition with only 2 conditions in it. And what we would do is we would just rapidly alternate between the control condition or the baseline condition and one of the independent variables. So picture this graph if we just didn't have the squares at all. That would be a 1 independent variable alternating treatments design that totally works. So usually when we do that, it's called a pairwise analysis, where we're like pairing 2 different conditions together. Usually that would actually be like the 2 different reinforcement conditions. So like usually we might do that. Actually, I think on this very chart, I cut it off a little bit, but on this very chart, they do a pairwise analysis between escape and attention. Where they go back and forth, and yeah, it's totally a cool thing to do with our alternating treatments design. This would differ from our withdrawal reversal design because we're not waiting for those phase changes. We're still rapidly alternating. And again, that's why the most important thing to nail down about this design is that we are rapidly alternating between our conditions. So that is super crucial. I feel like a lot of materials don't emphasize that enough. That is the main thing we want to focus on for this alternating treatments design. Cool, cool, cool. Awesome. Rachel's asking a question. Yeah, the dependent variable is always going to be on the y-axis. Our x-axis is going to be a unit of time. Always a unit of time. It's not our independent variable. The IVs are usually labeled by the phases or by the legend. So look at that. We're asking again a question. Do you think we would get a super tricky question like that in the exam? Yeah, why not? So it's totally fair game. All right, so let's continue. We went on a couple little tangents there, but that's okay. I think it's good stuff. For our alternating treatments design, visually identify this chart that, again, that's the thing that you want to look for, is that there's one data point that's different on each session, and we have multiple data paths. So different IVs on different sessions, where compared to our withdrawal design, we saw that we had the 2 data points on the same session, but in the alternating treatment design, every data point is going to be on a different session there. Cool, cool, cool. IVs are interventions, DVs are behaviors. So no, on that donkey. One other feature, a lot of you guys talked about this earlier too, is that baseline condition is optional. So we don't need to run a baseline, but we totally could run a baseline. The baseline would typically not just be alternated between, it would just be like raw baseline. We would want to have the same phase change patterns as withdrawal before we move on to our multi-element phase, but optional, don't have to do it. One option for the multi-element, instead of doing a baseline condition, is doing a baseline or a control condition that is kind of just thrown into the mix. So we saw that that in this chart, where we have our play condition is our control condition. It's kind of just thrown into the rapid alternation between all of these. A question: when would it be a good time to use a baseline? Sometimes it's just natural, like before you start your before you're even ready to do all of your alternation, you might already have that baseline data, so you might as well throw it on the graph. If you're not doing a control condition that's thrown into, baseline condition is cool. I would recommend it, and yeah, I think those would be the main situations. As far as utility for this design, you can test out many independent variables very quickly. So you can just keep alternating between them, and you can test out even 5 different independent variables very quickly. And that's a big advantage over our withdrawal design, where we needed those very particular patterns in our data paths before we could do our phase changes. So the rapid alternations allow us to test out those different IVs very quickly. When we're looking at our experimental control, again, we're always going to be comparing our level between our conditions. So we can estimate our level lines here. If you were here last week, this is actually the same chart. So we had this one's around 4. Our squares are right around 1, and then our triangles are right around 0. So we can make comparisons either to a baseline condition. We don't have baseline data in this one, but would be totally cool. We can do it to a control condition. So this would be our play condition in this case. So we could look at the difference from this 0 to 4 to this 0 to 1. Or you can also compare it between other treatment conditions. So how much more did it escape increase the behavior as opposed to play? Couple questions to chat. We have a question: is play always the control condition? Yes. Play is always control. Alone is not a control condition. It's a test for automatic reinforcement, so it's not a control condition. We have another question: should they be different response classes? No, we're looking at the same response class for all these conditions. Same DV. Alone condition is not a control condition. We have another question: is this design usually only used for FAs? No. So we'll talk about it in a sec, but pretty much all FAs are multi-element designs, but not all multi-element designs are FAs. So if you see these conditions, be like, yep, that's a multi-element. But just because you see the rapid alternation does not mean it's an FA. Alrighty. Let's keep going. So again, as far as utility, we can use this to quickly evaluate many different interventions. This is also the best design that we can use for severe or dangerous behavior. And the reason for that is because we can kind of relate it back to our features. We can skip a baseline. So sweet, we don't need to do a baseline at all. We can just get right into our intervention. And we can also test out many different treatments all very quickly. So if we're like not sure if something's going to work or not, then it's cool. We can just throw it in the mix and like we'll know very quickly if this is going to work or not. Alternating treatment designs, they can be used for irreversible behaviors. Kind of tricky on how this works. I'm going to draw a graph within a graph here. So with our irreversible behaviors, let's say we take a baseline and they like don't know how to like stay on their bike very long, out of like a 1 minute session or whatever. And then we use two different interventions. So we have like circle and square here. It'll be circle and bigger circle because I can't draw the small. So we have circle and bigger circle, and we have something that kind of looks like this. Let's say our data are kind of looking like this. So kind of like that and like this. So even though this is like an irreversible behavior, we can still use this alternating treatments design because it kind of like evens itself out, where this would actually be another sequence effect, where this one is called a practice effect. And this is essentially when the learning from a previous condition affects the next condition. But in the multi-element here, the practice effect kind of evens itself out, where they get equal exposure to each intervention on average. So like on this first data point, they're like totally raw, like they haven't learned anything. Now in this first data point for the bigger circles, we see like, okay, they had one session of exposure to the small circle intervention. Now when we go back to the small circle intervention, now they have exposure to one session of small circle and one session of big circle. Then we go to big circle. Now they have two sessions of small circle and one session of big circle. So it kind of like averages itself out and evens itself out, where we have this practice effect, where it's still cool because like we're kind of like laddering in how much they're learning from each one, and eventually it's going to average itself out. That would be different from like our withdrawal design, where it's like, okay, if we want to test out two interventions for that, we have like they learn it really well in the first one, and then we do another phase with a different intervention, and then they perform like this. Or like how much of that was learned in the previous intervention versus like what was caused by the last intervention. We don't really know. But like the multi-element, since it kind of ladders that exposure in, that practice effect, then it's totally cool to go. All right. So again, that's called, that would be a practice effect, and the alternating treatments design helps minimize that practice effect. Multiple treatment interference is something different. We're not going to hit on that today. All right. Alternating treatments design. This is also the graph of choice for functional analyses. So we saw that this graph is a functional analysis. Again, the rule is that pretty much like every time that you see a functional analysis chart, it's going to be an alternating treatments design, but not all alternating treatments designs are going to be functional analyses. But like it's a pretty much 99.9% rule. Like if you see like these conditions, like escape, attention, play, ignore, all that jazz, 99.9% of the time it's going to be multi-element. So pretty safe run through on those. Alrighty. Well, now that you learned about our withdrawal designs and our alternating treatments designs, we're going to put your skills to the test. Who's ready? All right, let's take a look at this graph. One thing I want to look at here before I hand you any questions is that just like how to look at a graph. So like you might see this and like, oh shit, this is a lot, and it's kind of intimidating. So a couple important things that I want you to orient yourself to is first thing when you do whenever you see a graph is you need to read the chart title. So this one says decreasing entry with a visual barrier. then it's important to kind of like look at the phases, what's going on with these. It's also important to like look at our y-axis label. What are we actually measuring here? What's our dependent variable? You might want to look at your legend as well, and then start looking at the data paths and try to make sense of it. So here's our first question. What kind of design do we have here? Is this withdrawal? Or is this alternating treatments design? Or both? Think about it. I want to see some rationales on this. Let's see those answers. A, B, C. A is withdrawal, B is alternating treatment design, or C is both. I don't want to see any answers without rationales here. So start doing that. Give me them rationales. Remember, what are those defining features of each design? Which of those features do we have here? Make sure you orient yourself to all of the different things. Look at the labels. Look at our dependent variable label. Look at our chart label. Look at that legend. Amanda, I might double check that. Amanda Cassidy. Amanda Scheckman, do you mean IVs or DVs? Mina, how are they being alternated? Gunjan, can we have a withdrawal design with multiple IVs? I know. And, yeah, a lot of people are mentioning like this is the difference between knowing the basics and being able to apply the basics. So this graph, like we talked about everything that we need to know to correctly identify this graph and analyze what's going on. But it's a farther step than just the basics that we had covered. So it takes a little bit of that initial insight, or like a little bit more like deeper insight, and really that ability to see things and break it down rather than just like, okay, this is that. So that's why we do this. It's important to look at graphs. If you're struggling with experimental design but you feel like you know the basics and like the different designs and stuff, it's like a really great exercise. It's just like Google like behavior analysis single subject design graphs and do these little breakdowns like we're doing here. All right, love all the effort that's coming in here. I love all the deep thinking. I love the rationales that are coming through. Yeah, Amanda Cassidy, I would like look at like a couple, pull out just like a couple data points and see if they line up or not. Yeah, we're going to do a more in-depth review of this chart in just a sec. We'll give you guys maybe 10 more seconds for the design question, and then we'll start looking at it. Yeah, sometimes your glasses are important to see what's going on in these charts for sure. I love it. Nice, Amy. All right. Let's go ahead and check this one out. The answer here is it A, B, or C? The answer is A. This is a withdrawal design. It's not an alternating treatment design. It's not both. Let's go talk about why. This one is a withdrawal design. So remember, key features of withdrawal design is that we're going to see a baseline and intervention condition, and then there's going to be a revert back to that original condition. So we see that here. If we're to label this, we've got a baseline, we've got intervention, we go back to baseline, we go back to intervention, then we try a different intervention. So we've got a C here, and then we go back to B. So A, B, C, B is the chart. Let's talk about why this is not an alternating treatments design. Couple different reasons that we can, or a couple different ways that we could see that. A lot of you guys were going through the strategy of like, okay, are these data points aligned up on every session, or do they alternate between each other? And if we see that like and all these data points actually, there's always 2 data points per session. So that's one indicator that these are behaviors and not going to be our different interventions. Another thing that you could look at, and I thought I told you, and I thought I gave it away. I thought I was giving it away too much, actually. But the chart title, decreasing entry with a visual barrier. Then we look at our y-axis label. Approaches and entries. These are the dependent variables. And we can also see over here in our legend, this labels our dependent variables, entry and approaches. This one is not an alternating treatment design. There are different interventions, but we see that the interventions are visual barrier plus redirection and redirection only. If we're looking at the entries and approaches, these are 2 of our dependent variables. That's why it's really important to get those basics down, IVs versus DVs, so we can see them in our charts more cleanly. So this one is going to be a withdrawal design only. I told you, whenever you see a graph, first thing you need to do, chart title, y-axis label, legend. First things you need to do every single time you see a graph. Chart title, y-axis label, legend. Every time you're going to miss, if you don't do that, you're going to miss a lot of these questions. So really great habit to get into. Chart title, y-axis label, legend. All right. Yeah, a graph can be both, but this is not it. So let's talk about this one a little bit more. We got entries and approaches, 2 different behaviors. We can draw some average level lines. I'm just going to draw 2 on each of these since we have 2 different dependent variables for each. Some of them, they line up. So first ones we kind of have at like 9 and 7 or so for average levels. Intervention here, we go down to like 3.5 and 0. On this next baseline, they all lined up. So that average maybe around 8 to 10. We can draw these next level lines, maybe around 3 and maybe around 1 or so. But we get some good stabilization towards the end here at 0 for both, which is kind of cool. We got a redirection only that goes up to about 5. And then we see this goes to like 0, and then this goes to like 1 or so. There's a lot of zeros here for our approaches, even though we had some outliers here. So again, to tell if we have experimental control, what we want to do is we want to look at the change in level between our conditions. So baseline, we had like 7 and 9, and this went down to like 3 and 0. Pretty nice changes there. Pretty nice changes overall. I would say that's significant for sure. And then we go back to baseline, and it goes back to our around 8 or so. So what occurred in this phase? What referring to baseline logic, what occurred in this phase, crew? Real quick. Nice. Yeah, good job, Mina, Rachel, Nika. This is going to be our verification here. So this is our first insight. We're like, yeah, we've got some pretty good experimental control. It's making some difference here. We might have not gotten like the full reduction we wanted to see on approaches, so that's why they put it back in and really check that out. So we put this back in, and then we see a little bit more variable data for a while. And then eventually it does kind of even out the last 3 data points here towards like near 0 levels. So that's pretty cool. We see that full reduction. Then what they did is they're like, okay, we were using this visual barrier plus redirection. What if we only use redirection? What would happen to the behavior? And what they saw is that, like, oh, it actually increases it and it kind of makes it a lot worse. So like, okay, no, we're going to go back to our previous full intervention. They did so, and then we saw it level out to like near 0 level. So definitely was effective towards the end there for sure. Some people were talking about the type of analysis here. This one is called a component analysis. So in this one, we have a treatment package which has both of these intervention components. Then we remove one component, and we're like, okay, does this work? And they're like, no, it doesn't work. So we put them back in, and that's our component analysis here. We'll talk more about those in part 3 of experimental design. Yeah, the labels on this one are very confusing. That's a good point, Mina. So what they did here, like, it looks like we don't really have the labels, but we have this visual barrier plus redirection. They just like weren't able to fit that into like this 3 data point phase. So what they did is that they had these arrows draw that's also labeling like, yeah, these were also visual barrier plus redirection. So maybe not the cleanest, but it was what they decided to do for this. Sometimes like what researchers will do instead is they'll like abbreviate it, so they'll be like VB plus R for like this smaller phase. So that may have made it more or less confusing. I don't know, it kind of just depends who you are and how familiar you are with reading graphs for sure. Yeah, definitely a little tricky there because it wasn't like a very clean label, but that arrow was supposed to draw that label over. Cool. So, yeah, just kind of wrap up what, this chart. Once again, we have a withdrawal design because we have our phases here, our 2 different data points. These are going to be our dependent variables. We have entries and approaches. Then we see on our y-axis, we have entries and approaches as well as our chart title. And then we have, the reversing of these phases. And we have pretty good experimental control. It had better reduction for our entries overall, but it also was saw some pretty good reductions on approaches. The component analysis that they did where they tried the redirection only was not effective, so they had to add that visual barrier back in to be effective. Merlin is asking, can we explain component versus comparative? You're going to have to come to part 3 for that. That will be next week. So stay tuned for that. All right. Well, that was a really tough graph, but I love to see all of the effort that you guys put in there. So how about we break it up with a little giveaway? Does that sound good? All right, the holiday season is here. Santa Nick is here. We're going to do some giveaways. Let's do it. All right, for this one, how about we do, what should we give away tonight? You guys have been pretty good. You guys have been very good on the good board list. Jolly old Saint Nick here. We're going to do 2 winners. 2 winners. And then if you win, you can get any of the Beat the Beast mocks, or you can get our fluency questions. So, 2 winners. Anybody, if you win, you can get your choice of any of the Beat the Beast mocks or our fluency questions. And, yeah, that's our giveaway tonight. So, let me pull up my random number generator. And if you haven't checked it out yet, I gotta plug it. Check out our Behavior B Slayer course. It has short videos that go over everything that you need to know for the BCBA exam. We've got 43 reviews on it, 4.93 stars. Students like it. It's the best test prep product out there. Everything is really direct, right to the point. It's fun. The videos are like 10 to 15 minutes long for the most part, so they're like really consumable. You don't have to like wait through a 2-hour video to like find the part that you want. So check that out if you haven't done that yet. And if you need the highest quality mock exams out there for an affordable price, we got your back there too. All right. So let's do this. We're going to do a random number generator, 1 to 500. Let's get this stupid thing out of the way. 1 to 500, our two closest people are going to win a mock exam. If you already have all the mocks and you have the fluency questions, maybe now don't participate. Let somebody else win. And yeah. I have a question. Are the mini mocks the same if you reorder them? Yeah, the mini mocks are going to be the same if you redo them. We also offer a renewal discount if you want to take them again. Our fluency package, just talking about that real quick, is that you can go ahead and take these quizzes as many times as you want. You'll get new questions every time. So that's kind of a cool thing. These questions are a lot easier than our mock questions though. So like mini mocks are our hardest. These mocks, pretty hard. Fluency questions, easy. They're just meant to be quick and easy to squeeze some studying in. All right. We've got lots of guesses here. 1 guess per person. Sorry, I forgot to mention that. It's looking like a lot of guesses because Merlin's got like 30 guesses here. Sorry, Merlin. We're going to have to disqualify you from this round. That's too many numbers. 1 guess per person. Two closest are going to get it. If you guess multiple times, you're not going to win. I promise you. Nobody's ever gotten away from it. It doesn't work, so don't try. All right, last call for guesses. All right, let's do it. We're guessing it. 2 winners on this one. Our number is 319. Let's see who's our closest, our 2 closest. 319. We've got Mina, 315. That's pretty close. Here, I'm going to pull this over here. See, some help here would definitely be appreciated. I'm always really slow at finding people. Okay, 319. I saw Mina was 315. Nobody else was really that close. 319, we had Rachel at 340. That's 21 away. We have Anicia at 333. That's only 14 away. Oh, and then Brooklyn at 330. That's only 11 away. Brooklyn 330, 11 away, and then Mina I think was just 4 away, right? Okay, is anybody closer than 330? Help me out here, crew. Where was Mina again? We had a 305. Who was 305? Because 305 would also be 14 away. Oh man, that might be a tie break. We might have a tie here for second place. Where was 305? So Mina for sure was only 4 away. Congratulations to Mina. You've been participating very well tonight, so you totally deserve it. Did we have a 305 and a 333? I'm not seeing this 305. I'm going to scroll through one more time. If you guys point out the 305, let me know if it's like top, bottom, or center. We had 304. Magdiel. That's 15 away. Oh, brutal. All right, maybe it was the 304. Okay. Well, we're going to give it to Mina and Anicia. Congratulations, you two. You guys just won yourself one of the Beat the Beast mocks or our fluency questions. To claim your prize, just send us an email, understandingbehaviorofficial@gmail.com. Let us know which product that you want, and we'll hook you up. All right, congratulations. Kayla, you had 333 too? What? Did you? Let me see that one more time. I'm not seeing that. Where were you at, Kayla? Oh, wait. All right, we're making a third winner. I missed this one. We had Kayla here as well. So Anicia and Kayla. We're gonna give it to all three, guys. We're gonna be nice. It's holiday season. Sorry I missed you, Kayla. You're also a winner tonight. Nick's got his big bag of mock exams and we're handing them out. Congratulations, Kayla. Thanks for saying something. You're also a winner tonight. Send us an email at understandingbehaviorofficial@gmail.com and let us know which prize you'd like and we'll hook you up. All right. Sweet. 3 amazing winners. You guys have been rocking it tonight. Okay. We're going to talk a little bit about multiple baseline designs, and then we're going to wrap it up for the evening. We're going to save changing criterion for next week. So next week we'll talk about changing criterion designs. We'll talk about complex designs. We'll talk about experimental analyses, and then we'll talk about internal and external validity as well. So good stuff next week. Hope to see you there. And then obviously we're going to take Christmas Day off. So no Thursday live stream on Christmas Day. I think the whole crew is taking that week off. So don't miss us too much and keep your starting up. And if you miss me too much, then get the Beast Slayer course. You can hang out with me still. All right, let's talk about multiple baseline designs. Let's go. In a multiple baseline design, we test out a single intervention. And the way that we show experimental control with this design is we replicate an A-B relationship across either different settings, people, or behaviors. Now, a lot of people are able to label these settings, people, or behaviors, but what would be the technical term in regards to our different kinds of variables? What would be these different settings, people, or behaviors? Let's see that in chat. We have Donkey Henderson with 2 guesses, but only one of them is correct. Heather's got it. Good, Heather. Heather from Michigan. I'm going back to Michigan for the holidays. It's not as cool as Colorado, but I'll be there. The fam's there. Take the 17.5-hour drive with my dog. So fun. All right, you guys are nailing this though. This is going to be referred to our dependent variables. It's the behavior that occurs in these different settings across different people or our different behaviors. So dependent variables was the word I was looking for. Colorado is sunny and beautiful. It's way nicer than Michigan. So if you're in Michigan and think about Colorado, it's no contest. Colorado is so much nicer. Today it was 65 and sunny. It's amazing. But the mountains, they have a bunch of snow. So we have more snow and better weather. It's the best. Anyway, enough about Colorado. Okay, so that's our multiple baseline design. We test our A-B relationship across these different settings, people, or behaviors. So note that this is only an A-B relationship. So this is not the best demonstration of experimental control because we never really remove an intervention. And we saw with our withdrawal design, A-B wasn't really enough to show experimental control. But A-B is only enough here when we replicate that across our different dependent variables. So kind of keep that in mind. Multiple baseline designs, kind of a weaker design in general. To visually identify a multiple baseline design, what we want to look for is that we're going to see stacked graphs. But more importantly is that they're not just stacked, but they also have a phase change line that kind of creates this staircase pattern. And what this does is that it shows that our baseline conditions have different durations. So we see for Rachel, we had 5 baseline data points. For Sarah, we had 10 baseline data points. And for Jackie, we had 15 baseline data points. So the differing duration baselines is a totally necessary feature for our multiple baseline design. Cool. So that's going to be our phase change line, and essentially, like, we want to compare the data from our baseline to intervention, and look at the data like for the intervention condition for our first intervention to kind of signal like when we're going to start our next intervention condition. So as far as like prediction, verification, and replication, it's a very similar pattern as we're going to use for our withdrawal design, but it's a little bit different because we don't have withdrawals. Same kind of thing, like for Rachel here in baseline, we've got 40 pretty stable pattern of data. So that indicates like, cool, we can phase change there. So our prediction would be like, hey, if we're going to stay with baseline with Rachel, it's going to hover around 40 and kind of continue across that trend. So in this chart, where we actually see a verification is with our second dependent variable. So look here, it's like we implemented the phase change with Rachel, and now this is where we're going to compare our prediction to. So in this phase right here in our second baseline, this is where verification is going to occur because we made our prediction about our baseline condition, then we verified it with Sarah's pattern of data. We do the same thing here. We can also make that prediction again that like, hey, this level and trend is going to continue. And that's going to be our prediction. And then we can verify that prediction right here in this part with Jackie, where we already have the intervention going with Sarah, but we're continuing to take baseline data with Jackie. So that's where our prediction, verification, replication comes in. And for our replication, we look at the levels of our different intervention conditions, and we see like if these are going to replicate. So at our end here, we get this stabilization around 80. And does this replicate with our next dependent variable? If it does, we're pretty cool. All right. Yeah, usually these streams go for about an hour and a half. 2 hours usually drains my voice. All right. Cool. So that's our prediction, verification, replication. And we demonstrate experimental control, again, by replicating these A-B relationships across many different dependent variables. So we want to see replication occur for a bunch of these dependent variables. You need at least 2. Usually, sometimes these will go up to 5. 3 is pretty standard, but essentially, like, the more the better. As far as our utility for our multiple baseline design, this is our most commonly used single subject design. I think the reason for that is just like it's easiest to run. Essentially, like, you're more likely to get good data with this design. So, and if you're like familiar with like research culture, like we usually if there is good data, then it gets published. But if you don't have good data, then it doesn't get published, which I think is wrong. But anyway, it's just how our world works. So these are easiest to run, easiest to get some good data on. So we see them are very common in our research. As far as experimental control, though, there is this is our weakest form of experimental control out of all of our designs. So we can kind of think about it like withdrawal is like really strong experimental control, where we show like those really clean removals and additions of IVs. Altering treatments design, just slightly above that, because we're not usually doing like clean removals of our IVs, but we like remove and replace. So it's like not much weaker, but it is a little bit weaker. Multiple baseline design is like a big step weaker. So think about like if withdrawal is like 100, the gold standard, altering treatments is like 90, and multiple baselines like 50, 60. But there's ways to enhance that as well. One advantage of the multiple baseline design is that we can use it to teach irreversible behaviors. So big advantage there because we don't need to have that removal. And it's a pretty flexible design that can be used for a wide variety of behaviors. So we could use this for problem behavior, or we could use it for skill acquisition behavior. One limitation is that it's just not really that great for our severe or dangerous behaviors, because some of our dependent variables need to be in baseline for a long time, and that is not ideal. We don't like that. It's not great. Cool. All right. Yeah, as far as like changing criterion designs are pretty strong too. So I'd give them like an 80, 90. We have a couple of variations of our multiple baseline design as well. The first one is going to be our multiple probe design. So in the multiple probe design, we are taking probes. A probe is essentially like a quick check-in on a behavior, or a quick measurement of a behavior, but it's not necessarily a continuous measurement of behavior. In the multiple probe design, these are only used for irreversible behaviors. So the reason we're able to take probes and it doesn't really matter is that we don't expect these behaviors to change in our baseline conditions, and we don't expect them to be unlearned in our post-intervention conditions. So look at our dependent variable on this chart. We've got percentage of words spelled correctly. So this is an irreversible behavior. If they never learn the words, then we don't expect them to learn the words in our baseline conditions. So we take the probes here. We see like we took 3 data points. Then we just like didn't measure it for a while. Then we checked back in right before the intervention. And then we took 3 more data points before we started our intervention. We also take probes in our post-intervention phases because we don't expect it to be unlearned. So we see that like, hey, they got the words down 3 at 100. Then we took a long break. And then we just checked in, like, hey, do they still got it? Cool, they do. Then we took another long break. Hey, they still got it? Sweet, we're good. So irreversible behaviors, and again, the key features here is that the behaviors will not be learned in baseline, and they won't be unlearned after our intervention. So we can take these probes because essentially like we're making predictions that's going to like stay, and then we like verify those predictions, and it's totally cool. We don't lose anything, and we save a lot of time. So that's our multiple probe design. We only use these with irreversible behaviors. Our other variation is our delayed multiple baseline design, sometimes called a non-concurrent baseline design. There's a slight difference between those, but it's fairly negligible. But essentially in a delayed multiple baseline design, we are doing our multiple baseline design, but there's going to be significant periods of time where we're not collecting baseline data before like we implement our intervention, or like even while we're taking baseline data for other DVs here. So that's our main difference with the delayed multiple baseline design. Non-concurrent might be that like we're not necessarily displaying these delays, but we like add in the dependent variables later. So let's say like we add in a participant to our study and it's like 6 months after we started the study. That might be more of a non-concurrent multiple baseline design, and that may or may not even be shown on the graph like this. So delayed, always going to have that delay in the start of baseline collection. Non-concurrent, kind of similar, but that delay may or may not be displayed on the graph. Cool. All right, well, that is going to wrap us up for the evening. Once again, if you haven't checked out our stuff at understandingbehavior.shop, make sure that you are signing up to our email list. I give some great study tips every week. I will send you some coupons, we'll send you free mini mocks, and we'll send you updates about when all of our awesome events are. So make sure you get on our email list. And check out our stuff if you are interested in getting some of the highest quality and most affordable BCBA exam prep stuff out there. But anyway, that's going to be all for this week. Next week, we're going to do part 3. We're going to talk about changing criterion designs. We're going to talk about experimental analyses. We're going to talk about internal and external validity and a bunch of other cool stuff. So check it out. Yeah, glad you've been liking the mocks, Valerie. That is awesome. Kathy, good luck on your test. I know we had a couple other people testing soon. Nissa, good luck on your test. Is there a way to reset the mocks? Yeah. For most of them, you need to pay. So for the full mocks, you can just buy another one and we'll hook you up. For the mini mocks, we offer a 50% discount for anybody who's renewing these. So check them out. Amanda Cassidy, good luck on your exam. Hope to hear some good news next week. Well, anyway, I hope to see most, if not all of you next week for part 3. Then we'll take a week off for the holidays, and then we'll be back in action going hard. But regardless, we'll be posting on Instagram. We'll post our daily questions, study tips, and all that cool jazz there. So check it out. Follow us. Do the things. Yeah. All right, cool. Well, thanks so much for being here, everybody. Thanks for all of your amazing participation tonight. Hope you guys have a lovely week. Go slay your tests or keep slaying your preparation. And I will hopefully see you next week. Is there any holiday discounts? We might announce them next week. I don't know. Be here. Anyway, that's all for tonight. Have a great night and see ya next time. Bye-bye.